so stuff we had last year, these are the same slides we used in Algebra 2. So most of it's review. The last thing we talk about is probably something new, but it's a pretty easy day. You're going to have to pay attention though, because it's been a while since you've talked about domain and range and functions a little bit. All right, so first thing we'll talk about is relation, talk about domain and range and function, and then we'll figure out if something's a function or not, a relation is a function or not, things like that. So first thing, a relation is a pairing of input values, which are x values, with output values, y. It can be shown as a set of ordered pairs, where x, again, is the input and y is the output. So I just say a relation is a set of ordered pairs. That's all it is. The set of input x values for a relation is called the domain, and the set of output values, the y values, is called the range. So the x values is the domain, the y values, the range. So if I ask you for domain and range, you just tell me what the x values are and what the y values are. Sometimes we can look and just list them. Sometimes it's a whole set of real numbers. Sometimes it's just all real numbers, but a single number sometimes. So there's different ways. And we might use some interval notation to do that as well. All right, so this is called a mapping diagram, and it just gives us the domain is 2 and the range is ABC. So I have 3 ordered pairs, 2A, 2B, and 2C. So that's my relation, this set of ordered pairs. Again, the x value is the input, and that's the domain, and the y value is the output, and then call that the range. Okay, so Nick, what's the domain of this relation? What else? Correct. Just the x values. That's our domain. What's our range, Tasha? Good. And you don't have to write it twice if it shows up more than once. You can just write those numbers once. Okay? Pretty easy, right? That's all it is. Okay, Ashton, what's the domain of this one?
Is -2, -1, 0, 1, 2, 3.
Very good. The x values are -2 all the way up to 3, just like you said. Carter, what's the range?
2, 1, 0, -1, -2, -3.
Correct. Very good. So what they did is they listed all the ordered pairs, and then they said, well, you don't have to list them. You can look at them and tell me what the x values and the y values are, right? Remember, this are the x values. So right here's the first one, -2, -1, 0, 1, 2, 3. And then the y values are up here this way, and -2 down, +2 down to -3. That make sense? So I expect you to be able to look at a set and tell me domain and range, and I expect you to be able to look at a graph and tell me domain and range. Any questions so far? Pretty easy, isn't it? You guys remembering this from last year, hopefully? Good. All right. So back when they first came out with cell phones, they didn't have the keyboard for you guys. They just had, your numbers that you used to dial. Then on a phone, each number represented three different letters. So if I had to text a word, if I wanted to use the letter M, I'd hit the 6 once. But if I wanted to use the letter O, I'd have to hit the 6 3 times for the O to pop up, instead of just the keyboard like you guys are used to, right? Like everybody's used to now. All right. So it says, suppose you were told that a person entered a word into a text message using those numbers, 6, 2, 8, and 4, these ones that they got here. All right. So there's, 1, 3, 6, 9, 12 different, letters that you could use, but what letters did they actually use? It'd be hard to tell, right? But if you knew they were supposed to type in the word math, then you know you'd hit the 6 once, the 2 once, the 8 once, and then the 4, I forget now. Once or twice, yeah. So you hit 6, 2, 8, and then you hit 4 twice, and then math would come up in your screen. You know, as you do that. So that's the old way they used to do it, okay? So they just showed you this because, you know, M could be or 6 could be 3 different letters, and 2 could be 3, you know, they had 3 different, but when you have a relation in which the first coordinate, the x value, is never repeated, it's called a function. In a function, there is only one output for each input, one y for each x. So each element of the domain is mapped to exactly one element in the range. So the way I think about it, for every x value, there's one and only one y value. In order for a relation to be a function is a special type of relation. Every x has one and only one y. Although a single single x value in a function cannot be mapped to more than one y value output, 2 or more different inputs, you know, I could have 1, 2, 3, can be mapped to the same output. So 1, 2, 3 could be mapped to 2. So I could have 1, 2, 2, 2, 3, 2. That's okay. You can have repeats in the y values, in the range. You just can't have repeats in the x's if you're asked if it's a function or not. In order to be a function, no repeats in the x. So this one was 2a, 2b, 2c. The 2 gets repeated. Shows up 3 times, right? The x. That's not a function. This one, a, 2, b2, c2, each one of these x's only had one y. No repeats, so it was okay. It is a function. All right, so it's okay to have the range repeat, but no repeats domain x. All right, so if I go to Mark's today and get some of that Superior's 2% milk, well, every one of those jugs of milk that type have one and only one price. Or will there be different prices? Just be one, wouldn't there? So that's what they're saying. Items in a store on a certain date, they're all supposed to be the same amount, right? So that's a function. That's an example of a function. Okay? Types of fruits and their colors. Do all fruits have just one and only one color? No. You know, grapes are purple and green. Apples are green and yellow and red. So that's not an example of a function. Okay? They're still relations, both of them. Sets of ordered pairs. But one's a function, one's not. Shoes. You got the size 7, 8, 9, the price $35. You know, are the prices going to change if you get somebody with a really big foot? You're still going to, you know, if you're getting the same type of shoe, usually they're the same price, right? Unless it's some monster foot, that big foot or something like that, might be more. So there's only one price for each shoe size, so that's a function. All right? If I go to Mark's and then Ashton goes and we both get 10 items, are we going to have one and only one price, or will there be multiple prices of 10 items? You know, we all could go and get 10 items, right? And all of us could have a different price, couldn't we? Depending on what we get. So that's an example of not being a function. So just trying to get you to think about what constitutes, we have a function, what we don't. Every x, think about it, domain has one and only one y, one and only one range. Some sets of ordered pairs can be described by using an equation. When the set of ordered pairs described by an equation satisfies the definition of a function, we can write it in function notation. So here's function notation. You guys have seen this before. F of x, our output value, our range, equals 5x, x being our input domain, plus 3. All right, so f of x equals 5 times x plus 3. That's function notation. All right, if they ask for f of 1, that means to substitute 1 in for x and figure it out. So f of 1 would be 8. 5 times 1 is 5, plus 3 is 8. So my ordered pair would be 1, 8. Does that make sense? You guys remember that, I hope. Again, you're used to y equals 5x plus 3, but it's f of x equals 5x plus 3 is the same thing. Okay, both of these functions are the same set of ordered pairs. Again, a graph is a picture of all the answers. All right? Something like this would be a straight line. Just have a y and an x in it. Straight line, that's a function. Again, it doesn't mean f times x or f multiplied by x. The value of f, it means the value of f at x. So f of 1 represents the value of f at x equal to 1. All right, so we have an example of some relations, and you're supposed to tell me if we have a function or not. So let me see what this relation looks like. 2, 3, 4, 1. And 4, 5. So I have a set of ordered pairs, a relation here. Is that relation a function? No. Why not? This x, the second x, the 4, has 2 different y's, right? That's not a function. All right, so if you see a repetition in the x's when it's listed like that, check the y's, make sure they're different. Like if this was 4, 1, 4, 1, then it'd be okay. But 4, 1 and then a different y, 5, that's not a function. How about 3x plus y equals 1? You know, I could get y by itself. Will every x have one and only one y? If I plug any number in for x, will I get just one y? Will it be multiple y's forever? You know, it's a straight line, right? If you have an equation with an x and a y in it, no exponents. It's a line and it's a function. The only line that's not a function is one that's vertical. Okay? So if you got an x and a y in it, yes, function. Okay? If you have just y, you know, that's a horizontal line, that's okay, that is a function. But if you got a vertical line, that means x is always 3, like 3, 1, 3, 2, 3, 3. So that x has more than one y. So that straight line would not be a function. How about this one? Negative 4x squared plus y squared equals 9. When the x and the y are both squared, what is that a picture of when we graph it? Circle, very good. That's what we had last week, right? So if I draw a picture of a circle, I don't know if that's the right circle, but I'll just, make a circle. Will every x value have one and only one y value? Let's say I pick the x value 0. Right here. There's my x value is 0. Okay? Well, will that only have one y value, or are there more than one? There's more than one, right? There's a point here that's 0 something. Let's say that's 0, 3. And this one is like 0, -2, let's just say. Okay, so for when x is 0, I got 2 different y values. That's not a function. Okay? So if you see a problem tonight on homework or on the quiz next Tuesday, if you see an x squared and a y squared, if it's a circle, it's not a function. It's still a relation. It's still a set of ordered pairs, It's just not a function. Okay? Also, if just the x is squared, remember it's a parabola that opens up or down. Yes, that would be a function. If it's a y squared only, maybe x plus y squared, that might have been, x squared plus y. As long as just one of them is squared, you got it looking like this, right? That's not a function. Okay, so if both are squared or the y is squared, it's not a function. If x is squared, it is a function. If it's just x and y, it's a function. If it's just y equals a number, it's a function. If it's just x equals a number, it's not a function. Okay, so I'm just trying to give you all the examples that you might see. I don't think we'll get anything higher than an x or y squared. Not cubes yet or anything. All right, so that's like example 3 in your book. You have a few problems where I'll give you a couple equations and you'll have to tell if it's a function or not. Example 4 is asking for the domain of a function, which means what again? The x values, right? So here's our function, g of t. They'll use different letters once in a while. And instead of x and y, they're using t and g of t. All right, so what's the domain? What are the possible values of t? Can it be all real numbers? Usually we start at all real numbers. And then we work our way back if we don't think all real numbers would work. Are there any numbers that t is not allowed to be? I heard something. 4, yeah. Why isn't t allowed to be 4?
0.
That'll give me a 0 in the denominator, right? Very good. Not allowed to have 0 in the denominator, right? So we would say our domain would be all real numbers, and x cannot equal 4, something like that. Or if it said to put it in interval notation, that's when we're using, parentheses or brackets. We did some of that at the beginning of the year. All right. So if I had to show this domain, all real numbers but 4, it would look like this. Negative infinity, 4, parentheses on both, union put together with 4 to infinity. Since I use parentheses, that means I'm not including the 4. So basically I'm saying everything but 4 then. Okay, so you might have to do some, you'll have to find the domain of different equations. Another one that you might see is f of x equals x plus 1 in here, and a square root, okay? Are there numbers that x can't be in this problem? Or can it just be any number I can put in for x? So I could say all real numbers for my domain. What do you think? Somebody said negatives, right? We allowed to have negatives under the radical sign? No. That gives us that imaginary unit, right? That I. So we can't have negatives under there. So this, whatever's under the radical sign's got to be 0 or bigger, right? Can't be negative. So you write that. Whatever's under the radical sign, to find the domain, is you put it greater than or equal to 0. And then we're going to subtract 1 to solve for x, and that'll be our domain. So if I put any number, negative 1 or bigger, it's a function. Okay, it'll work. I can do it. So I would just write this for my domain. If I get a number like negative 2, and I get negative 2 plus 1 would be negative 1, and the square root of negative 1 is I, right? It's like the imaginary unit, so it's not a real number, so We can't use anything less than -1. -1 or bigger is our domain. Possible X value. Remember, domain X values, range Y values. Mr. Walls, what's F of 0? Mhm. Very good. Kyle, what's F of 1/2? 10, is that what you said? You are correct. 4 times 1/2 is 2, 8 plus 2 is 10. Okay, Sydney, what's F of -2? Very good. Because we're going 8 plus 4 times -2 is -8. 8 plus -8 is 0. Any problems with those? Making sense? Liam? Good? All right, Liam, next slide, F of 0 is for you. You ready? Okay. What's F of 0? Remember, F of 0 means, what's the value of F when X equals 0? So, look at where X equals 0 and then find the red line. Yeah. Okay. So you go find where X is 0 right there, then go find the red line, it's up there, that's 3. That makes sense? John? F of 1/2.
0.
Good. You go find 1/2 on the X, and there's the red lines right there. That's 0. Okay? Cody? F of -2? Good. We go find -2, and then we go find the red line, it's up there at 4. That makes sense to everybody? So, if it's in this form, I expect you to be able to find the F of 0, 1/2, whatever, F of anything. And the same thing when it's in graphing form. When you see a graph, you should be able to find one as well. Okay? Since this keeps going, right, because those arrows, what's the domain? All real numbers. What's the range? From what you can see right now, what would you say? From 4 down. Y is less or equal to 4. Does that make sense? What if these stopped? If these weren't arrows? Oops. Let's say that was a dot and that's a dot. Let's say it's halfway between. What's the domain then? From -5 to 3.5, right? You see that? How you can look at a graph and tell domain and range? Okay, does that make sense? You guys are good. Such smart CP math students. In the notation f of x, f is the name of the function. The output f of x is of a function is called the dependent variable because it depends on the input value of the function. The input x is called the independent variable. We can put whatever we want in place of the x. When a function is graphed, the independent variable is graphed on the horizontal, which is our x-axis, and the dependent variable is graphed on the vertical, or the y-axis, right? So independent to our domain, because we can make it anything usually, and then our range, our y, our output, is the dependent variable, because it depends on what we put in for the independent variable. All right, here's the thing that you might not, that's new for you. The rest of it's basically review. A piecewise function. So they call it P of X, just for piecewise. And it's just got more pieces. Instead of one piece, this one's got 3 pieces. Okay? And for this example, P of X equals 2X when X is less than negative 2. P of X equals X squared when X is greater than or equal to negative 2, but less than 1. P of X equals 4 minus X, that's the third piece, when X is greater than or equal to 1. So we got different domains for each piece. Okay? So that's what a piecewise function looks like. So then they're going to ask you, well, what is P of 3 equal? So what piece does that belong to? The top, middle, or bottom? Okay, Ashton? Okay. What do you guys think? No, P of 3. Where does 3 belong? Top, middle, or bottom? Yeah, the bottom, right? Again, this is, remember, oh, I should have put F, I should have put P, right? Because it's P. So P of 3, meaning my X value is 3. That fits here, right? It doesn't fit in either one of those, right? So what's 4 minus 3? 1. Okay. What's P of negative 4? Top one, right? Negative 4 fits here, right? So what's 2 times negative 4? Negative 8. What's P of negative 1? That's the middle, right? Negative 1 fits between negative 2 and positive 1, right? So what's negative 1 squared? 1. That making sense? And what if you had to graph that? You have to graph all 3 pieces, wouldn't you? Okay? So, let's just go and put it in here. What do we got? One was 2x, wasn't it? And the other one was x squared. And the other one was 4 minus x, right? I think I remember that, right? Didn't I? The first one, 2x? Yeah. Okay? So, hit graph. There's the 2x. There's the x squared. There's the 4 minus x. Now let's think about this. Let's think about our domain. What's our domain again? What are we thinking about when we're thinking about domain? X values, right? So remember, our domains were x less than negative 2, negative 2 less than equal to x less than 1, and then x greater than equal to 1, right? Those were the 3 domains. Okay, so here's what it looks like. This was the first one, the 2x one. That's this domain. From negative 2 this way, right? From negative 2 this way. With me there? Not including negative 2, right? That's why I got a circle there, right under the negative 2. Here, including the negative 2, up to, but not including the 1. So it's this this little curve here. Not including the 1, so at the other end I have a circle, not including the 1. I got a dot including the -2, see that? And then from 1, including the 1, this way, is the third piece. That's what that looks like. If we were to take this out of here, you know, put our X, our Y-axis, a little bit close, but in our X-axis, you know, looking like that. Okay? So just kind of give you an idea what a piecewise graph would look like. But all you're going to do is this part. I just wanted to show you so you can kind of see. You're just going to do, oh, let me get rid of this. Oops. Do that. Do this. Move that down. Move the top. This part. Whatever P is of the number, find where the number fits on the right here. Wherever it fits on the right, plug it into the 1 to the left to get the answer. Okay? So that's what's a little different. So domains are X values, range are Y values. A relation is a set of ordered pairs. A function is a relation where every X has 1 and only 1 Y. You're going to have to, find some domains, ranges, look at some equations and tell if it's a function or not. Look at some equations and find a domain. You got a fraction. Remember, whatever makes the domain or the bottom 0 can't be part of your domain. All right. Usually it's all real numbers in most situations. There you go. 3 to 24 by 3s. Not too much. The first 3, though, you got like 4 or 5 answers, but it's just plugging into the function. It's not bad. You guys did well on your quizzes Friday. Much better than the first one. Good job on that. Keep up the good work.